So today we'll be discussing on the solution of the exercise which I last gave. So that was an L3 VPN, and we have to create a service model for the L3 VPN. And the first question which came in was when do we use the service models, and when do we use the golden configurations. So there are two things which we do on the network equipments. So one is the initial configurations on the equipments to set them up for possible VPNs or possible services. So in order to do that, you have to do some infrastructure configurations like the interface IP addressing, the MTU size, the SSH configurations, how to SSH on the device, how to manage the device, SNMP strings, how do you set the SNMP strings, how do you set the authentication, and a normal IGP protocol. So IGP protocol is your dynamic routing protocol, which will make all the devices reachable to each other. So all these configurations are not service. They are configurations which enable you to set up the network so that you can set up more services on top of it. So all these type of configurations come under golden configurations. So why golden configurations? Because there's a standard way of doing it, and you have to have a similar kind of configuration on all the devices. And if there is any deviation, the user should be informed about the deviation. So that is why we call it golden. So the word golden means that it has to be standardized and it should be similar on all the boxes. It should not happen that you have a different logging methodology on a box and a different logging methodology or a different SNMP string on another box. Means that is possible when there is a scenario for it. Means suppose you have got two boxes and both are for very different use, then of course this is possible. But otherwise, if it's a single service provider case, this doesn't happen. So that is why you have to use the infrastructure golden configuration everywhere. So these configurations would include your VTY configurations, like your username, passwords, how do you manage, or the AAA configurations, the SNMP configurations, the dynamic protocol configurations. So all these come under your golden config. Now, what is the service config? So service config is the configurations which you use to make these devices serve other customers. Let me give an example here. I hope my board is visible. So this is suppose a service provider network with 1, 2, 3, 4, 5 routers. So in order to make all these routers talk to each other, you have to make certain configurations. This interface should be in the same subnet. This interface should be in the same subnet. These two same subnet. These two same subnet. These two same subnet. Then for all the routers to talk to each other, you have to use some IGP. So IGP means your routing protocol. Internal gateway protocol. Internal gateway protocol. So you can either use OSPF or ISIS. So these protocols you use to make all the routers reachable to each other. Then if you want to use MPLS, then you have to use LDP, Label Distribution Protocol, for the labels to be distributed on all the routers. So all this configuration will come under golden config, because by doing these configurations, you are making the service provider network ready, but you are not connecting any customer, you are not providing any service service as of now. But after this is all done, you want to give services to your customers. So suppose this is the first customer you want to connect to this router, and another customer you want to connect here on this router. I call it C1, I call it C2. So now this C1 will talk to C2 using this service provider network. So this configuration for connecting C1 to C2, that is giving the service, goes in the service configuration. So if it is an L2 VPN, it will be an L2 VPN configuration. If it is an L3 VPN, it will come as L3 VPN configuration. And this configuration will be on a set of routers. And you will consider all the configuration on different routers, which is there for providing service for one customer as one service. And there comes the service model. Okay, let me explain again. Golden config is same configuration or similar configuration like this. A, B, C, D, something like this. This has to happen on each router. But this is same set of configuration on each router, and this is individual router. Okay. Now for a service, so it is not happening that this configuration, if it is not there on one router, then there is some service which is impacting. There is no service. There is the network itself, the infrastructure itself, which needs this configuration. Now for the service model, you have, suppose, one customer with multiple branches. So this customer C has, suppose, 3 branches. So there is C3 also. So now all the configuration on this router, and this router for making this VPN work becomes part of single service because it is for this C customer. So there you make use of service model so that you can configure multiple boxes to give service to a customer. Okay.
So basically, a common set of commands we can say the GCT can run.
Yes, common set of commands come under GCT. Common set of infrastructure commands, not the service commands, come under GCT, and the customer specific service configurations come under service model. So that is why you make the service model so that there could be n number of customers, but the service would remain same. If it's an L3 VPN service, it would still remain the same. There could be n number of customers, so you can keep configuring those L3 VPNs for multiple customers. Okay. So now another thing about L3 VPN. So first what we did was we made all these routers talk to each other. We configured ISIS or OSPF. We configured LDP. So now all the routers are talking to each other and they have the labels also getting distributed. Now we want to configure L3 VPN. So in order to configure L3 VPN, we have to configure another protocol called BGP. So why BGP? Because BGP is the protocol which helps taking the customer routes from one place to other. So what happens is, suppose this customer has this route 192.168.0.0/24 here in his LAN. Now this LAN wants to talk to the other office LAN which might have 192.168.5.0/24 in the LAN here. So this LAN subnet wants to talk to this LAN subnet. So you need an L3 VPN to make this happen. So this is the customer route. 192.168.5.0/24 is the customer route. So you will have a customer router here which will send these routes to the PE router. So PE router, I think I already told all of you what is PE router. Provider edge router is the PE router, which is the connecting point for the customer. Okay. So once your PE router has this route, now where it will put this route in the overall routing context. So the global routing table of these boxes have the routes to connect between each other. Now, if I make this route also part of the global routing table, then what will happen is this customer will also become part of the service provider network. Service provider routers can talk to customer, customer can talk to all routers. This is not what we want. We want a separation for this customer. So this route has to be put in a jail so that only the other side of the customer should be able to talk to this route. So we use something called VRF, virtual routing function. So this virtual routing function, we name it like a customer name or a service name, that if the customer was suppose Infinity, so we will name the VRF as Infinity. And we will put this route inside the Infinity VRF. And from Infinity VRF, we will tag it with a route distinguisher and use BGP to distribute this route to the other PE. Okay, so BGP can be used to distribute IP routes. Now, how BGP will come to know? Because VRF is local to the router.
To the router of the customer or to the global router?
Local to the PE router. So only the PE router knows about the VRF. That this is the space in the routing table given for a particular customer. But now when you are advertising the route using BGP to the other router, how would BGP know that this route
Has to go to this.
It will know that it has to go to this PE. But how will it know if there are multiple customers here? So BGP should also not mix the routes. It should always know that this route belongs to customer Infinity or customer A. So how it will come to know is, so this route on the PE is tagged with a unique identifier called RD, route distinguisher. Route distinguisher. So route distinguisher is a value which is attached on top of, because this is a private network. This can be used by multiple customers. There could be other customers also using similar LAN 192.168.5.0. How will I distinguish them? If it is using a different LAN, then still I am safe. But I cannot force the customer to use a different IP. Customer can use any IP, whatever he wants. So in order to differentiate that, so I will create another VRF for this one, and I will use another RD in the VRF, so that when BGP is taking care of, so BGP is, so now you see the problem that there are two similar routes, and if BGP carries both the routes here, then there is no differentiation. If the traffic comes for this one, it can go to this one also, because this one is also saying that this route belongs to this one. So how will I install the route in a specific VRF? So I need an RD value to distinguish between the routes and an RT value to install the routes.
So the mapping होती है इसके VRF और RD के बीच में, तो वो 1-to-1 की होती है.
Correct. So when you define the VRF, you define the RD also.
But VRF is already unique, na?
VRF is already unique, but all the routes within the VRF, when the BGP takes that route, you put an RD, you associate an RD value. So think like this, that BGP will not take the VRF along with. Okay. So VRF is a name, like a string, but BGP needs a numeric distinguisher to distinguish the route. So each VRF is associated with one RD value. BGP makes use of that RT value. Okay. And RT values are used to at the destination to install the routes. So we say that in this VRF, install route target this, and that customer routes gets installed. So this is the overall. So now in BGP, what happens is the configuration uses BGP AS number. So AS number is a unique number which identifies a whole network. So if it is a single network, it will have, all the routers will have single AS number. So this is a single service provider. So suppose the AS number is 1. So BGP will have AS number and it will have neighbors. So neighbor means the IP of the remote router. So this PE, if it wants to make a BGP association with this, so this will have the remote IP of this for the neighbor IP in the configuration. Once it is ready, then it can start exchanging the routes. So with this, so this is like a very brief overview. I don't want to get into how the label swapping happens and all for L3 VPN, because that is like, you must know what L3 VPN is, what is the overview of configurations to understand the main objects in the configuration, but I think that is enough. And in case you are interested, you can Google L3 VPN and you will have a lot of material to read about and to understand how the L3 VPN works. So now if I show you the configuration here, this is the configuration of PE11, and the first configuration itself is the VRF definition. So VRF, when you define a VRF, you are giving a name to the VRF. VRF definition VPN 10001, and then you are saying RD 1:0001. So you are defining the VRF along with the RD. Now there are two address families available. So one is address family IPv4, another one is address family IPv6. So depending on the IP addresses your customer is using, if it is using an IPv4 address, you can use address family IPv4. If it is using an IPv6, you can use address family IPv6. So now we are using address family IPv4, and we are just saying exit address family. So means we are enabling the IPv4 address family in this VRF VPN 1001. Now we are saying import route target 10001 and export route target 10001. So import and export is used for BGP to install the routes. So whatever we are saying import, we are installing it, and whatever we are saying export, we are advertising it. Now this is the interface. So this was the VRF configuration till here. Now after that, we have the interface which is connecting to the customer. In the picture which I drew a line from PE router to CE. So that this is the interface which is used to connect to the customer. So there we are saying we are making the interface part of that VRF, because otherwise it will not be jailed. So we have made interface part of VRF here, VRF forwarding VPN 1001. Then we are giving the IP address, which is the LAN IP address for the customer. So we are giving one of the LAN IPs here, IP address 172.31.1.1. Then exiting from here, then we are saying interface gigabit 0/12 and another interface. So here the customer is connecting to us on two interfaces. So customer has two LAN. So it has asked for two interfaces, you can see here. Both the interfaces are part of same VRF forwarding VPN 10001.
So this is the connection between the provider
and customer router. So it could be single connection, it could be multiple connections. So this is like two connections are happening from the PE router to the customer router. Now, this is done. After this, the BGP routing protocol. So router BGP AS number. So AS number, I told it's 1. So we kept AS number 1 for the router BGP. Then address family IPv4. And then we are saying VRF VPN 1001. So what does this mean? So this means that we are dividing the BGP also into VRFs, and in the VRF we are making a BGP neighborship towards the CE router. So we are saying neighbor 172.1.1.2 remote AS 65001. So 65001 is the AS number of the customer. And why this IP is 172.1.1.2? Because the customer is connected to us with 172.1.1.1, 255, 255, 255, 252. So this is /30 subnet. So how many IPs can be there in /30 subnet? 2 to power 2, correct. So 4 IPs, out of 4, only 2 usable. So, sorry guys. So 1 is used on the PE router, 172.1.1.1. So if you are connecting the customer on the immediate next, then you will use .2 in the customer router. So that is what you have used in the BGP. Understood? Because you are making the BGP neighborship from PE router to the customer router. So .1 interface pe use kiya, and .2 you have used on the customer router, and that's why you are making the neighborship. Similarly, for this interface, you have used 31.2.1. So 2.2 will be your customer. And then there are some BGP attributes, like you are saying that activate this neighborship. You are saying allow in AS, allow AS in 3. Then you are saying AS override. So all these configurations are for the AS numbers that you are putting 65001 AS as the customer AS. So you can override that. So that's why you are putting all these configurations. Same configurations you are putting for the second neighbor. And these configurations are given to you by the network engineer. Then you are saying redistribute connected. So there are 3 kind of routes in the router. Mainly 3 kinds of, there are more also, but 3 kinds of routes are important. One is directly connected routes. So directly connected routes are routes which are the networks available on the interfaces of the router. Directly connected ka jo Hindi meaning hai, it's that only, that the router is directly connected to this network. How the router will be directly connected to a network? Because that network is available on the interface of the router. Understood? So those are directly connected routes. So you are saying redistribute connected means within the VRF, this IP 172.1.1.1, instead of this, the BGP will take the route 172.1.0/30. 1.0/30 is directly connected route, and it is advertising to the other PE. It will advertise it to the other PE so that these IPs, both these IPs 1 and 2 will become reachable. And then you are saying redistribute static. So if you have put any routes in the VRF, static routes in the VRF for other networks in the customer LAN, you can advertise those also to BGP. So that's what you're saying, redistribute static. So redistribute is the command which is used to redistribute the routes from one process to other. So in the BGP process, if you want to redistribute something, you say redistribute, and you say whether it is connected routes you want to redistribute, static routes you want to redistribute, and then you're saying exit address family. So this is the configuration for your PE1, and similar will be configuration for your PE2. So now, in order to make the Yang model, you have to differentiate the variables. So VRF definition, this VPN 1001, this is a variable. So let us call this 1001 as the VPN number or VPN ID. So we make a Yang leaf which says, first we make a Yang list which says the L3 VPN Yang list, and then we make the leaf which is the VPN ID. So 1001 becomes VPN ID. Then we use the RD values. We make another leaf which is RD value and we use it as 1:VPN ID. You see, we want to reduce the user inputs. So RD, either we can make a leaf, or if we don't want to make a leaf, we can skip making it leaf, and directly in the template we will say RD 1:VPN ID. Then route target also we are taking the same. So 1:VPN ID becomes our route target import export. Then interface, of course, gigabit. This interface we'll have to make a leaf for this, so that we take user input, because user will decide where he has to connect the customer. So this one leaf we will have to create. Then VRF, VPN forwarding. So again, VRF, we already know it's VPN and VPN ID. So VRF, here also we make VPN plus VPN ID becomes our VRF. Then IP address is something we need to make a leaf for. So because this will keep on changing, when the customer changes, this IP will be defined by the customer. So this one we have to use from the user input. So customer IP address and the subnet mask. So this will be single variable. We can make two variables. One is the IP address, one is the subnet mask, so that customer can have either a /252 or /248, whatever customer wants to use as the subnet mask can be used. Leaf ref कर सकते हैं आप. So if you make it leaf ref, so whenever you will select a device, you will get all the interfaces from the device, and then you can select from that. So either if you take just the leaf, then the engineer has to input it manually. If you make it leaf ref and you give the path, then automatically it will give you the drop down list of all the interfaces available on the box, and you can select one from there. Then for the router BGP, you have to choose this one as AS number. So AS number you take as the customer input. Then this is VRF is same, VPN ID, VPN plus VPN ID. This IP you can calculate. So you can, if you are using a Java package, if you know this IP and this subnet, and if it is 252, then the next IP will be used here. Or if you want to make just make this configuration work, then you put this also as a variable. Neighbor IP, you put another variable, and you can ask for user input. User has to give, but then the possibility of making mistakes increases, because user can put any IP there, and if that is not the correct, then the service will not work. These are all static variables. 65001 is the remote AS, which you have to take user input. And that's it. Similar stuff you have to do for P31, the other router. So this is like, once you have created the Yang model, you can use it for the other router also. But on the template, you have to use two different routers as router 1 and router 2 configuration, and make all the variables work in the template as we did in the first exercise. So once you have this ready, you will be able to make the VPN. Aftab has a working L3 VPN. So there he has also made the choice of routing protocols. So here inside the VRF, we have run BGP. You can see BGP router 1. So you can either use BGP as the CEP protocol, you can use RIP, you can use OSPF, you can use ISIS. So there is an enum kind of structure which Aftab has used in his service model to give user a choice that what kind of CEP protocol you want to use. And based on the user choice, he has made WAN statements that if the user has said that he will use BGP as the routing protocol between CEP, then BGP specific configurations will be asked by the from the user, or else the static route configuration, or else the RIP configuration will be asked from the user, and the same will be applied to the. So that's how this L3 VPN package can be made. Any questions or anything which bounced?
नेबर्स का जो रोल है, जैसे नेबर्स जो आप बता रहे हो,
हाँ जी,
मैं बेसिकली उस राउटर्स के जो सपोज मैं एक ए राउटर से बी राउटर के बीच कम्युनिकेट कर रहा हूँ, ठीक है, और उन राउटर से मेरे पी कनेक्टेड कस्टमर कनेक्टेड है, तो वो हमारे पी हो गए, राइट?
करेक्ट.
तो जो नेबर्स की बात कर रहे हैं, उस केस में वो नेबर्स उसका बी वाले का ए हो गया और भी हो सकते हैं.
Okay, so there could be multiple neighbors in terms of PE. So PE is mainly PE routers are most of the time full mesh. Full mesh means all the PEs have neighborship with all other PEs, so that they can exchange routes from anywhere to anywhere. But your customer neighborship will be within the VRF, and that will be specific to the customer.